Okay, so first and foremost, this is AWS dashboard. So this is your console. As you know, there are many ways you can interact with AWS resources. One is through the console, that is through this web platform, and another one is through the CLI. Right, you can go into your terminal and be using their CLI tool that is called AWS, and just be writing commands and then be creating and then working with your resources. So I'm just going to be using this to work for now. And then so right now I'm currently logged in as an IAM user. As you can see, I'm an IAM user. So first and foremost, when you create your account, you are going to be having the root user, right? And then for you to have an IAM user, you have to go to the IAM roles, IAM users, IAM roles to create IAM roles, because it is actually recommended that you don't use the root user to, for your everyday logins, right? So you need to create an IAM user so that you can be able to, just for security purposes, you create an IAM user, for your everyday login. So I've created an IAM user right here with this name. So that's what we are going to be using to be working. So let me just go back to the notes. So first and foremost, we will just be at the website, and then you sign in, register, all of that. And then the first thing we want to be doing is that when you want to upload an app, right? Because what we are doing here is we have a task to deploy a full stack application that has a React front end, it has a Python backend, and then a relational database, which is Postgres, right? So firstly, what you want to do is you have to create something called a VPC, right? And then what is a VPC? A VPC is like a virtual private data center. It literally means virtual private cloud, right? Virtual private cloud. So it's like your virtual data center. Just like in organizations, you may have some kind of room somewhere, right, where you have all your IT resources and there are ACs and all of that inside. So this is like mimicking that environment for you. So when you create that VPC, you are going to be storing all of your resources, like your what's it called, your servers, your networking devices, your routers, and all of that. All of your storages, all of them are going to be going in there. So a VPC is where you are going to be housing all of these things, right? So firstly, we are just going to create a VPC by, because Amazon has like hundreds of resources. So in order for you to locate those resources very quickly, you can just go to the search bar and search for VPC, right? So VPC, and then click on VPC. So as you can see in this dashboard, right, you can be able to see all your VPCs, your subnets, routing tables, internet gateway. So all of these they are all related to the VPC, right? We'll talk about all of these things later on, but let's just go into the VPC resources right now. Alright, so as you can see, if you are just creating, or if you are just opening your AWS account for the first time, when you go into this VPC resources, you notice that there is a default VPC that has been created for you, right? That has been created for you, and it even has some kind of configurations like subnets, routing tables, and all of that by default. But then what we are going to be doing is we are going to be creating our own VPC so that you see how it's done. So you just use the button create VPC, and then we want to use VPC and more, so that we can have a look at all of the subnets and all of that, and then edit them if we want to, right? So after that, on the VPC settings, click on VPC and more. So auto generate needs to be true, right? And then you provide a name tag, right? So let's just give it task app. Let me say task app 2. so that it's going to be differentiated. So this auto-generate is just going to be helping me auto-generate all of these names, all of these additional names, descriptive names, right? So I'm just going to be putting task app 2 so that it differentiates from the initial task app VPC that I've already created. So next up is the IPv4 CIDR block. Right, so this IPv4 CIDR block is like an IP block that you have to give to that resources. So this is just to say that we are going to be using this IPv4 address within that VPC. So every resource within that VPC should have an IP address within this range. Right, and this is like a private IP or a local IP. Right, a local IP. So it's not going to be. It's just going to be like an IP address that the resources within that VPC are going to be using to communicate with each other, not with the outside internet. Right. I hope we know what an IP address is and why we need them and how they work. Is there anyone that doesn't know how IP addresses work? Okay, so if anyone wants to say something, you can just maybe raise up your hand or open your mic and talk, because I can't see that interface from you. So this is IPv4, right? So this just means that as you can see, there are. Let me just open my notepad and show you how some of these IPs work. So as you can see, this IPv10 dot, let me just write it out here. Write it right here. So we have, let me just give a quick explanation on. So this is the 4 octets of an IPv4, right? So it has 4 octets. That is why it is called an IPv4. And in every of these octets, you have 8. What is it called? You have 8 ones, which is 8 binary numbers, right? So it has 8 binary numbers. So it is from these binary numbers that you can be able to calculate the IP address, the network portion, and the host portion. Right? So because in every IP address you have the host portion and you have the network portion. So I think I should not be going deep into this. So what I would just want you to understand is that whenever you see an IP/16, it's called a CIDR IP address, CIDR, right? And when you see the slash, any number you see at the slash means you have 16 network portions, right? So in 16 means you have these 8 numbers matching the network bits. That is why you have /16, right? So if the first octet 8 and the second octet 8 are for the network IP address, then that is to say that the last octet, which is also 16, belongs to the host IP, right? So if you are being asked in this IP address, in every network address, how many hosts are you going to be having? You just simply count the number of octets and say 2 raised to power the number of octets. So let's just give an example and say 2 raised to power 16. So that's 65,000, right? So in this IP address now, we are going to have 65,000 hosts, right? 65,000 hosts. So when you do subnetting, then you are going to be having, from there you can start having more number of networks and more number of hosts. So that is just, I will not really go deep into all of this, because AWS has really made this very easy for us, right? So because when I even came to do all of these things, I saw that AWS can have really made it easier. It's just for you to just click and just, even if you just know the second network IP address, it just automatically do everything for you. So as you can see, 65, you are going to be having, in this network, you are going to be having 65,000 IP addresses that's going to be available within that VPC. So that VPC, just look at it as your data center for your own organization, right? And if we, okay, let's just finish all of these configurations first before we look at the diagram. So IPv6 header block, all right. IPv6. Okay, no IPv6. We're not going to be using any IPv6, and then tenancy. So we'll just leave it as default, because if you select dedicated, we are going to be giving a dedicated hardware, which is a server, like a physical server, which is going to be more costly for you, and you don't really need a dedicated server except for very high security reasons like that. So next up, we just select number of availability zones, right? So what are availability zones? Availability zones are just like AWS data centers, right? AWS has built a lot of data centers around the world, but first and foremost, you have to know what a region is, right? A region is any location, right? It is any location where these data centers are located, right? So, like for example, now you have Europe, Stockholm. So Europe, Stockholm now is a region. It's a region where you know we are going to be having a lot of AWS availability zones within that region, right? So within this Europe, Stockholm, there are a lot of availability zones, right? So, and what are availability zones? Availability zones are locations where data centers are hosted. So you can see how nested it is, right? You have a region, you have an availability zone, then you have data centers, right? So because even inside these availability zones, you are going to be having at least 3 data centers, and all of these data centers are going to be at least 100 kilometers apart, right? So we're going to be selecting 2 AZs so that we can have high availability, right? So and we're selecting 2 AZs just so that if one of the AZs encounters any problem, AWS can quickly switch us to another availability zone so that our applications will not have a lot of downtime, right? So number of public subnets. So public subnets are now like a partition of your network, right? So within this VPC now, because you know within that data center, the availability zone, we are now having VPC, right? So within we can just say the VPC is like on the level of your account, because within your VPC you can have multiple availability zones. You understand? So so we can have 2 subnets, right? We can have 2 subnets, right? So what is a subnet? A subnet is like a kind of a partition, a network partition, like now say within your organization you have your whole network, right? But then you can partition a network in such a way that you can have IT department network, you can have finance network, you can have sales network, right? So every device within each of these networks are going to be able to easily communicate with each other. Like all the IT guys within the IT networks can easily communicate with themselves, all the devices within that network, and then finance, and then sales as well. You understand? So it's like a kind of a partition you do for your networks. So in AWS sense, what AWS does is that if you have subnets, you're mostly going to be having public and private subnets, right? So not like departments and how we do it physically. How AWS handle their own subnets is that they're going to be having public and private subnets in every availability zones. And the reason why you need this public and private subnets is that some resources need to be accessed from the internet, right? So every device on the internet will be able to reach those resources that are located within that subnet, while some other resources you don't want them to be public facing, right? You just want only your own devices within your network to be able to access them, but not other devices and the internet. That's why you put them in the private subnets, right? So example of such resources is your database, right? So your database needs to be placed in the private subnets, right? So let's go on. So gateway, we're not going to be talking about gateways for now, because it's going to be a bit more complex for what we are doing right now. And then VPC endpoint, so just select S3 gateway. Okay, so we're going to create our VPC. So a VPC with all the subnets and all of that is going to be created for us. Note that it also has routing tables, routes and all of these things. Maybe in our future classes we might talk about all of these routing tables and all of that. So I just click on View VPC. So this is the like the VPC dashboard, where I can find all the information that I need that is going to be pertaining to my VPC, right? So as you can see, we have in our VPC we have 4 subnets, 1, 2, 3, 4. These are the 4 subnets, right? And then we have public in the first availability zone. This is an availability zone, right? We have 1 public, 1 private subnet, and in the next one we have the same, right? So these are routing tables that help us manage the communication within all of these sub networks, right? And then these are connections and all of that. So we have successfully created VPC. So if you want to see all of your VPCs, you just go to this VPC, click on that link, and you see that now I currently have 3, right? The default one, the one I created earlier, and this one. So next thing we're going to be doing is because we're supposed to be creating our our backend server, our EC2 backend server, and then our Postgres server. But then you need to manage security and communication between all of these things. That's why the next thing we're going to be looking at is security groups, right? So and we're going to start by creating our backend security group, right? So we just search for security group in the search bar. And click on this security group. Okay, so as you can see, I already have a lot of security groups. But then a quick summary about security groups. So what are security groups? So security groups are kind of like a security layer for your AWS resources, right? So security groups sit at the resources level for your AWS resources. So what it means is that security group allows you to manage what protocols or what devices, or what identifications can be used to access each and every resources that you have. Example, the EC2, the database, and all of that, right? So and it mostly works using protocols like TCP, SSH, all of that. As you know, they are like a kind of a network communication protocols like that. So you have to define all of that in order for you to keep your resources secure. So we're going to start by creating a backend security group, right? Let me just look at the naming convention. So I'm going to use task app backend. So I'll just add a number to differentiate from the earlier one that I've done. So I'm just going to be adding the security group name, So this is where you just put all of the details for your security group, right? So I'm just going to call it task app backend security group 2, right? So I'm just going to give a description. So but then before we do the description, how do we want our backend to be accessed, right? How do you want it to be accessed? So our backend needs to be public facing, right? I know the lecturer, the tutor has been saying our backend is not supposed to be public facing. That is true if you have what is called a load balancer. That is what is going to be helping you route traffic between your resources. But in this case, we do not have a load balancer that is going to be collecting our requests, right? So definitely you have to let your backend server communicate with the internet. If not, there is no way your backend server can be accessed, because there is no load balancer that is going to handle all of your requests. So we want our backend server to be accessed on port 5000, right, which is a custom port. So what we are just going to be saying is that we're going to allow, okay, and then secondly, we need to also SSH into the backend server, right, using the SSH protocol and SSH command from our terminal, right. We are going to be remotely connecting to that server. So let me just give this description. So we are going to be allowing SSH HTTP. Okay. We are not going to be allowing HTTP, and because they are going to be on port 5000, and HTTP is on port 80, and HTTPS is on port 443. Right? So we are not doing that right at the moment, because we'll just say TCP. So we're going to allow SSH and TCP connection, right? And this TCP connection is a kind of a protocol that allows reliable communication, right? So it's going to allow reliable communication over the port that we specified, which is port 5000. So that's why I'm just going to say I'll just say SSH and TCP, right, which is going to be port 5000, and TCP will allow us to communicate reliably to the server, right? So allow SSH and TCP connection. SSH and TCP connection, access to the internet, right? Because anybody with that IP address can be able to use the TCP connection, which is that port 5000, to connect to that, which is this. Let me just show you, so that at least you have some things to be taken about while I'm explaining. Okay, this is a local, but we are going to update this, right? So we'll just know that this is the port 5000 we're talking about, and we want a what's it called? We want a TCP connection. So don't be confused about this HTTP, right? This HTTP, it doesn't mean port 80, because you're already specifying port 5000, which is a custom port, because I made that mistake earlier on to put port 80. So someone's mic is on, so we just keep that as our description. And then the VPC, so where do we want this security group to be associated with? Because you have to associate all of your resources with a particular VPC. Just like I've told you, your VPC is like your data center, so everything has to be within that data center, right? So let's select this VPC that we just created just now. and then we're going to add inbound rules. Right. So first, let's start with the type of rule, which is like the type of protocol we want to be adding. Let's add SSH, right? And you see that automatically the protocol is what? TCP. Because so just like I've explained to you, TCP is the kind of a connection-oriented protocol that allows reliable communication, right? A reliable packet transfer over the internet, right? So things like your email, and this platform itself, they all use TCP. And then things like streaming sites like Netflix and all of that, they use UDP, because they want to give you live data. They don't care about losing packets along the way, right? So that is why you have, on that layer, on that transport layer, you have these two main protocols, which is TCP and UDP, right? So the TCP will allow us connect reliably from our terminal into the server, and the port that SSH uses is port 22, right? And then for the source, we'll just select custom and we'll say anywhere, right? And then the second protocol we are adding is custom. Custom, like a TCP, yeah, custom TCP, and then we provide the port 5000. Because it's custom, it allows us to add the port that we want to use for our custom TCP. And then for the IP address, we just say anywhere, which is 0.0.0.0, which literally means internet, right? Because we don't specify any IP address here. That is to say, we are allowing connection to the internet, right? So as you all know, you don't need to specify outbound rules, right? So all of the traffic that you allow from here to come within your server is also going to be allowed out. So when somebody makes a request to your server, right, they are allowed to also get a request back. This is why we say outbound rules, all traffic, and then to the internet, right? You want to ask a question? 53, you can ask your question.
What does anywhere means? Anywhere IPv4 source.
Anywhere, okay then. So anywhere, it just means the internet, right? Just like we selected anywhere here. Anywhere IPv4 means internet. So it means any device that has an IP address can send a request to your server. Right? So if I select my IP address, you see it changes, right, to this 102. So right now, at the moment, I'm the only person that has this IP address, even though there are some kind of netting and all of that. So let's just not talk about that. Just imagine that only me now has this IP address in the whole world. So I'm the only person that is going to be able to use SSH to connect to this server, right? So, and the reason why I'm not just using my IP address is just so that maybe when I off my system and come back, my IP address is going to change. NTN is going to give me another IP address, so I don't want to be coming back here to now start selecting my IP address again. It's going to be very hectic. Although if you are making an SSH connection to your server in a production environment, you need to specify IP addresses, right? Because definitely your organization is going to have their own IP address that you're going to be using, because all of your public resources are going to be having IP addresses. So you definitely have to select an IP address here, right? So that it's going to be more secure. It's going to be harder for a hacker to SSH or to connect into your network, because if they don't have this IP address, they cannot connect. So I just want to say anywhere here just to ease my working at the moment. So let's just move on. We are allowing two protocols, which is the SSH and custom TCP, to make requests. Inbound rules means they are going to be able to make requests to the server. Right? Hope I didn't change anything here.
Hello, sir. Sorry, I'm asking a
Okay. Okay, all right, go on.
Sorry, I want to ask. Can you hear me?
Yeah, I can hear you.
Hello?
Sorry, you mentioned something
I said the
like
impact.
or maybe often your server and your IP address get to change. I don't understand that part.
Okay, so right now, let me see now. I just created the server, created the SSH, what's it called, the security group, right? So I then off my what's it called, my router. Say I'm using MTN router now, and then I off my router. So what do you think will happen when I come back and on my router again? Do you think I will still have the same IP address that I had initially? Definitely not. My IP address is going to change, because that is how IP addresses work in the telecoms industry, right? So long as we are using MTN and all of that, we are not buying a dedicated IP address. That's why when you go to organizations, you see that they buy dedicated public IP addresses. So if you don't have a dedicated public IP address to your name, whenever you are using MTN and all of that, your IP address keeps on changing whenever you off your network and come back, right? Whenever you off your device and come back, definitely your IP address is going to be changing. And there are a lot of technologies around how all of these IP addresses, how nothing goes on, how your because the IP address you get is not a public IP address, but then you can still use it to go on the internet. That is possible through what is called NAT, network address translation. But we don't want to go into all of that at the moment. Just know that when you off your device and come back, your IP address is going to change. I don't want to be coming back to be allowing my
All
IP
right,
address all
sorry.
the time. Yeah.
So sorry, sir. So how do we go around that now? Since our IP address is bound to change every time.
Yeah. So that's why I told you just select anywhere here.
Okay, sir. All right. Okay.
Yeah. Just select
All
anywhere,
right.
and
Now
you are good to.
understand. Thank you, sir. Thank you so much.
Yeah. So just click on the button, create security group. So our backend security group has now been created, right? So this backend security group is now going to be available within the list of our security groups. And whenever we are creating a resource, we can easily select that to provide those what's it called, that security settings to any device or any resource that we are creating within our VPC. It has to be within that VPC. So you can just come here, security groups, and you see that this is the security group that I just created. Task app SG2. Alright. So what we want to be doing next is we can just use this opportunity to create all of our security groups, so that we don't have to be coming back here to create security groups. So let me just reference the notes. Okay, because I remember I made this correction earlier, but I didn't correct this description. So it's just supposed to be TCP access to the internet, TCP, which is port 5000. Right, security groups. So next we are going to be creating our database security group. So why are we creating another database security group? Does anyone has any idea why we are creating another security group specifically for our database? Any idea on why we are creating another security group? So the reason why we are going to be creating another security group and not using that for security group is that the networks we want to be flowing into those resources are different, right? What is it called? The request. So the request for our database is mostly going to be coming on port 5432, which is like a Postgres port. So you can look at it like as a protocol, right? So it's a TCP protocol for Postgres, which is on port 5432. So let me just reference the name. I'm going to give it here. So we'll just say task app. So as you can see, there is all our security groups are having SG, so it's like a best practice for you to use SG when creating or when naming your security groups. So I'll just add a 2 here to differentiate. And then so our description is going to be, we're going to be allowing PostgreSQL access to our backend security group. Right. So we are now allowing Postgres access to backend security group. Why not to the internet or to another device, to another resource? We'll see why we do that later as we continue. So on the VPC section, we have to make sure we are selecting the right VPC where all the resources are going to reside, and then we add a rule. Right. So we are allowing what Postgres access to our backend security group, right? So what should we select here in the protocol? Anyone knows what we should select? Because we are allowing Postgres access. So what should we select now? We are going to be allowing Postgres traffic, or Postgres protocol, or Postgres port to be accessible. So the type of protocol we are going to be selecting here should be PostgreSQL. So as you can see, automatically you see that the protocol is what TCP, and the port range is what 5432, which is the port that by default Postgres use for data communication. And then remember we have TCP because we need a reliable transfer of packets, a reliable transfer of data, right? And then where should our traffic come from? Which IP addresses are allowed to communicate to this via this port, via this Postgres port?
Is it our IP? My IP?
Okay, not really, because remember, I told you that Postgres database should not be accessed to the internet. Only the right resources that need access, only the resources that need access to your database should be able to have access to your database. Because when you leave your database open to the internet, what does it really do to you? Like, what's the importance? What's the rationale behind leaving your database open? Nobody interacts with the database except your own applications. So only your front end needs to be allowed on the internet, just so that people can use their browser to connect. Right. So source is that we want to allow custom, right? And in this search, we want to allow our backend security group, which is this that we've created, right? Do you understand what I'm doing here? So what is actually happening here is that what I'm saying is that I want the source of this traffic to be from any device or any resource that has this security group attached to it. Even though we have not created our backend server yet, but our backend server is going to have this security group attached to it. Do you understand what I'm saying? You see that as we're going forward, our backend server is going to have this security group. So what we are just specifying here is that we want the source of the traffic to only come from any device or any resource that has this security group. So we are not specifying an IP address here. You understand? We are not specifying an IP address. We are not specifying a specific device, right? We are not specifying a specific network. All we are saying is that if a resource has this security details, right, let them come in. Just like you are saying, anybody that has this particular ID card can come in. I don't care whether you are a male or a female, a child or an adult. You understand? If you have this security detail or this ID card, you can come into this party. You understand what I'm saying? So unlike the first security group that we created, we were saying what? We were saying that the okay, no one even remind me that we've already created. Okay, we've not created our server. So it's just saying that that resource, all that resource need is that it needs to have the security group for the network to be allowed to access our database. Do you understand? So we're allowing Postgres access to the backend security group. So I'm just going to be having only one inbound rule. Right. So even if we have another server within the same VPC, within the same subnets, if we do not attach the security group to that server that we're going to be creating, they are not going to be able to access this database because of this subnet. Right, I hope you understand. So our outbound routes by default is going to allow every traffic out. Right, going to allow every traffic out. So as the traffic comes from this device with the security group, it can also go out. Right. So that's the only protocol that we need. We'll just go on to create our security group. So we've just created two security groups, one for our database and one for our backend. Even though we've not created the database yet, and we've not created the backend server yet, right? So, but then because we need them while creating those resources, right? So inbound rules. So as you see, the type is going to be Postgres and source custom. And then backend security group, the smaller search bar, and then SSH. Do we need SSH connection? We don't really need SSH. Do we need SSH connection? Do we need SSH connection to the database? Anyone has any answer? Do we need SSH connection? Please, if you are getting confused, please just ask your question. You say what?
Yes, we do.
What do you do?
We said we need SSH connection to the backend.
Oh, okay. So you don't actually need SSH connection to the backend.
Okay.
Yeah. So I made a mistake while typing this. You don't need SSH connection. So SSH connection is where you are going to say SSH and then you provide the what is it called? You provide the you say SSH and then you provide the IP address or the domain name of that server. Right. So you don't really need that. But let me just go and confirm in the earlier one that I created. DBSG. Okay. This is the first one I created. Okay, I added it here. So it's also a mistake. We don't need SSH. We don't need SSH protocol because all we are going to be using is the Postgres. Because we are just going to use Postgres protocol to connect to the server. I'll just keep that there just in case if you have any issue, we'll just come back to it. But I don't think we need any SSH connection because you just need SSH to SSH into a server and then do your work. Alright, so I'm not going to be any SSH into the into the Postgres server. So next we just create. Okay, we already created it, right? DBSG, this is the one, and then we added only one protocol. Only one protocol was added. So let's just move on to create our Postgres server. Right, so I'm just going to search for RDS in our AWS search bar. Search for RDS. So click on Aurora and RDS. Right, and then you can click on databases, or just create, or let's just review. So you see, as you can see, I already have one tax app DB. So to create a database, just click on create and say full configuration. Right, so then you just reference that. RDS, click on create subnet group. Okay, we're not supposed to create an RDS just yet, because we need something called subnet group. You see, that's why I'm telling you. You also even need to learn AWS on its own. You understand? You don't just go and start using AWS like that. You need the AWS knowledge on its own. So you need something called subnet group, right? So we're supposed to. So I'm just supposed to even say search for a subnet group. Subnet group. Right, so let's just search for subnet group first. Then I'll explain to you why we need a subnet group. But I might have been using the subnet groups here.
Sorry, I want to ask, why didn't we create a front-end security group?
Okay, the reason why we are not creating front-end security group is that we are not going to be having any front-end server. Right? Just like the instructor said, we should host our front-end on S3, right? So there's not going to be any need for a front-end server. So that's why we're not going to have any what's it called? Any front-end security group.
Okay.
Yes. Yeah, so this is just the database that I have here. Okay. You see what I'm saying? Submit groups.
Yeah, so I think it's all done submit.
Okay.
You've seen it, right?
Yeah, I've seen this is the subnet group I created.
Okay, yeah, that is it.
This AWS is just so bulky. Okay, I think I selected subnet group for DynamoDB. That was why. Okay, so I don't have any subnet group for this DynamoDB. That was why.
So I think this subnet group is found under the Aurora and RDS, right?
Yes. So you have to go under Aurora and RDS, and then you go to subnet groups. So this is the first one that I created, right? So you just have to be very careful in the places where you keep all of your resources, because if you mistakenly place your resource where you are not supposed to, you really it's going to be very difficult for you to troubleshoot. And initially when I was even doing I don't even know how I did it. I noticed that my region changed. So I remember I was looking for a resource and then I couldn't find it. Then I just noticed that my region was not the same. I had to go back, switch my region, then I could see all of my the resources that I was looking for. So
hope you remember the region you changed to, in case if you want to terminate your resources.
Yes, all of my resources are here. Yeah.
Okay, then Europe.
Yes, Europe. Yeah. But initially, that time I was looking for the resource and I couldn't find it, and I noticed that this was not the same. Understand? Yes. So you have to be very careful with because they are the same names, and you find out that you create it and then it suddenly falls on another resource or another region or another subnet. Right? So this is the first one that I
Is it
created.
advisable? Is it advisable to use the same region in all your works?
Same region. Just like
Like
yeah,
selecting the same region so that you don't get lost.
yeah. So selecting the same region, it just depends on, because when you look at the production aspect, right? You want to keep your resources. You want to keep your resources in a place where you have most clients, where most of your clients are based. If most of your clients are within EMEA, which is Europe, Africa, and all of that, then you have to use a region that is within Europe. That's why automatically when you are in Nigeria and you create your AWS account, you should be using this what's it called, this region, because it's closest to you, and then they just assume that your what's it called, your users are going to be within that region as well. You understand? So when you go and select US, there's this region that is very popular. This US East one. When you go and select this US East one, which is very far from Nigeria, and then most of your clients are from Nigeria, they're going to be having a hard time connecting to your services, because there's going to be a lot of latency and all of that. So let's not waste time on all of that. Let's just go on to create the DB subnet group. So let me just reference. So but then why do we even need a subnet group in the first place? Does anybody know why we need a subnet group? We are going to be creating a DB subnet group. So just like the name implies, right? Subnet group, right? So we are going to be grouping subnets, right? We are going to be having groups of subnets. So within one subnet group, we are going to be having 2 or more subnets, right? So, and how this is used in real life is that you want to be creating groups of your public subnets and another group for your private subnets, right? Just so that you know that, okay, within this group I have my public subnets within different regions. Within different regions I have my public subnets inside this group, and then within another subnet group I have my private subnet group and public subnet groups. So why do we even need to group these subnet groups in the first place? Why do we need to group them in the first place? The reason why we need to group our subnet groups in the first place is that AWS has something called managed services, and it also has unmanaged services, right? So what are managed services? Managed services are those kind of services in which the resources are or the services have, like, AWS manage a lot of some settings and some management for you for that resource. Right? So let's say maybe database. Postgres database is a managed resource. So AWS helps you manage things like replication, things like backup, things like scaling as well. So AWS manage these resources. That is why you need to tell AWS that if you are scaling these resources, so scale them within this subnet group. And within your subnet groups, you have your public subnets. Within one subnet group, you have what? All of the subnet groups within that group are what? Private. Right? So if we are looking at Postgres, for example, right? If you have a subnet group for Postgres, right, and then within that subnet group, you have private subnets. So AWS is only going to scale your resources within those availability or within those subnets that are what? Private, just so that AWS does not scale them into the public subnets. Do you understand? So that is one of the reasons why we need a subnet group. So enough of the talking, let's just go straight into creating one. So create the subnet group. Right, so we're there. You have to make sure you don't make any mistake. And then tags up. So we want to name the subnet group task app 2, right? And then we give a description. Just like I was explaining earlier, you see our description says private subnet group for Postgres RDS. So we are going to be having a group of subnets that are what? Only private. Only private subnet groups are going to be here. So we have to select our VPC. Right, VPC is where we are going to be attaching the subnet groups. Right, so for the availability zones, okay, so let's AWS has automatically selected these two, so let's just select them. All we just need to be careful about is to make sure that we are selecting only private only private subnets. As you can see within this region, I have this availability zone, right? And within these availability zones, I have two subnets. As you can see, I have two subnets. One is public and one is private. So I just want to make sure that I'm selecting only the private ones. You understand? So only my only my private subnets is what I'm selecting. So as to say that wherever because AWS also manages the availability zones. Somebody's mic is on. AWS also manages where they place these databases, because as I told you earlier on, RDS is a managed resources. It's a managed resource. So AWS decides on where to place those resources, which subnets and which availability zones to place those subnets. Your own task is just to specify and tell AWS where it should place those resources. Right? So we're placing them within our two private 1 and private 2. Right. So next up, so we're just going to review this, and then you see, as I told you earlier on, this header block is still within that 10.0.0/16, but it has been broken down into a subnetwork. That is why you have /20 here, right? /20. So I will not really talk about that so that we don't confuse ourselves. So you see, our availability zones is this availability zone. So we are using two availability zones, right? And then these are the subnets that we're using. We're using the private and the other private subnet. So just click on create. So I now have two subnet groups that we're going to be using to tell AWS to place our database inside of this one. Okay, VPC should be correct. Okay, let me just make sure that I selected the right VPC. So that I don't come on experience surprises later on. Okay, yeah, that's up to. So on the right VPC. So what next? So select the right VPC, select the availability zones, and create. So next up, we are going to be creating our Postgres instance. So let's search. Click on database on the left. Okay, we have to search. We have to search for RDS first. RDS. Okay, so we just want to create Express and so on. I want to do Express. Let's just go to database and then we want to select full configuration. So click on this button and say full configuration. Right. So from here we can select database engine, which is Postgres. So our database engine is Postgres, right? And then method full configuration, right? And then the template, we want to use a free tier because we don't have money to pay for database. Database engine PSQL 17.6. Engine version, is it engine version? Okay, engine version 17. Let me just select 17.6 R. 17.6 R2. So 17.6 R2. So the reason why we have to make sure that we are selecting the right version is that in a lot of cases when you don't select the right version for a specific tool, inside the code that you are deploying, right, that there might be a need for some specific feature in another database engine that might not be in the one you selected. So, and even though all of your configurations are correct, but it's just that the engine is not the same, you are just going to be experiencing a lot of issues. So that is why you have to make sure that you have all of these information from the developers. They give you the version of all the packages, all the tools, even the OS they used. You understand? They have to give you the correct version so that you deploy the same identical resource on the internet, on your servers. Because a lot of times, if you don't select those correct versions, you are going to be having a lot of issues. So we select that engine version, and then the DB instance identifier. Let's copy this. Instance identifier. So we just add a 2 here for differentiation purposes, and then master username. I think the login ID for master. Okay, let's see master ID, master username. So I'm going to be using as app user. So it's going to be the username that we're going to be using to connect to Postgres. Right, and then credentials should be self-managed, and then password. We don't want to generate password, but I think I already have a password that I'm going to be using, just so that I don't have multiple passwords. I'll just use the same password. Okay, it's not. So just create a strong password, and then create a password, and then database authentication option, password authentication. So we want to be using password for our authentication, which is this right here, which is this. So we're going to be providing our username and password for authentication, right? And then instance configuration. And then instance type should be dbt4g. dbt4g. I think this belongs to the free tier version, so they don't have to charge us for that, for excessive charging. So storage, I have to allocate at least 20 GB, right? And it's storage option. So you just have to leave. Just have to leave all of this as default as they are, right? So and while using this note, if you notice that some of the options here are not within this note right here, all you can do is just skip them and just leave them at their default. So we don't want to attach any compute resource. Okay, we don't want to connect any EC2 compute resource. So we are not attaching any any server to this to this Postgres database that we're creating. We're just going to be SSHing into or using the protocol to connect into the Postgres database, and then we'll do all of our operations. So network, we just want to leave only IPv4. We don't need the IPv6 for now. If you select this, you're going to be having two IP addresses as your public IP address, which is IPv4 and IPv6. So we just leave it as IPv4. So the virtual private cloud, just like I told you, any resource that you're creating, you need to tag it to a particular VPC or your data center. So I'm going to select this tax app VPC that we created for this demo purpose, and then the subnet group. Right. So we have only one subnet group within that. Okay. So the subnet group that we created earlier on, before we started creating this DB. So this is where you select the subnet group. So you see, choose the DB subnet group. The DC subnet group defines which subnet and IP ranges the DB instance can use in the VPC that you selected. So you see, it just helps you what's it called? Defines which subnets, which are going to be only our private subnets. Right, so our DB is going to be only within our private subnets. We don't want it to be public. So database will handle, AWS will handle which specific subnets to place them inside, or which specific availability zones to place them inside. So is it a public access? Not a public access. DB should not be public. So the VPC security group, we've already created a VPC security group, so we just want to come here and then select the security group that we created, which is supposed to be our tax app DB security group. This is for our backend server that we have not created yet. So we just want to select this security group. And so we only have DB security group that we connected. So, and this tax app DB security group is only going to allow what Postgres traffic on port 5432 into that Postgres server. Right. So availability zone, we can just say we can just leave it at no preference, and then but we can also select where we want to place them. So just like I told you, AWS is able to manage where to place this database resource for you. But as I told you, Postgres is one of the managed services that AWS offers. Right. So we just want to use standard monitoring, which within 7 days performance history and all of that. So this is just pertaining to how AWS is going to monitor the database for us. So we'll just leave all of this as default. Right. So we'll just leave all of this. This is also an AWS service. We don't need to talk about that just now. So this is just like a kind of summary around the cost and all of that. So we'll just click on create database. Yeah, so we have our database being created. Next, we'll just move on to creating our backend server. Right. So we'll just let this continue creating, and then we'll just go and search for EC2 so that we'll create our backend server where our Python code is going to be hosted. And then we're going to assign that backend security group so that only that server will be able to access our Postgres database. So what we want to do is we want to click on the launch instance button manage instance for our EC2 instance. So this is like the big boy. EC2 is like the most popular and the most used or the most popular resource on AWS. So it's like the backbone for almost every resource that you see on the cloud. So it's just like the server, just like you know, even on premise, the server itself, the physical server itself is like the base where you have everything installed, right? So you can have a front-end server, a back-end server, and even the database server is also installed on the server, right? So it's just like the base for almost all of the resources. Even S3 buckets and all of that. S3 buckets that stores image files, videos and all of that is also based on the EC2 server. So the only difference between EC2 and some other resources is that AWS is going to be giving you a server or a virtualized server. So and EC2 is not managed. That means it is self-managed. You have to manage your server by yourself. That is to say, AWS does not handle patching for you, right? It does not handle all of those maintenance and all of those things for you, security and all of that. So you have to manage all of those things by yourself. That's why we did not host because we can host our database server on an EC2 instance, right? But we did not do that because we want AWS to manage all of those things for us. That is why AWS have a lot of managed resources. So right now, we want to create our own server so that we can host our own Python backend server on this server. So let's just name this server. That's our backend server 2, right? And then we want to select the iOS image, ISO. It's called ISO. So ISO is like the operating system. The operating system that is going to be running on that EC2 instance or on that EC2 server, right? So, and these are a couple of popular options. And let's go into Ubuntu. So there's something very important right here for you to really take note of. And what you should notice here is that AWS automatically selected this Ubuntu 26.04 LTS version for you, right? So this was one of the errors that I encountered while I was doing mine, right? So because if you go back to those videos, you see that the instructor used version 24, and this is automatically selecting version 26 for us. The reason is because Ubuntu 26 just got released recently, so it's a new version of Ubuntu. Because if you've been working with Linux, you know that for a very long time we've been using Ubuntu Server 24, and that project that was hosted was used Ubuntu version 24, right? So while I was creating mine, I just used this as it was selected by default. Then I noticed that I was having a specific package error, right? Some kind of weird error that did not even allow the Python code to even run at all, right? And that was also coming from one of the requirements that the project was using, which was a version of something like, I think, Cycop or something, and it was not having an engine that will run it within this new version of Linux. So it took me hours before I was able to debug that the problem was coming from here. So don't make that mistake. Make sure you select Ubuntu Server 24 LTS. Okay, let's let's confirm the changes. So I'm going to be using Ubuntu 24 LTS. I think I've not even corrected. Okay, I've corrected that here. Right, Right, so I'm going to be using Ubuntu 24, and then the instance type should be T3 micro. T3 micro, which has a free tier, which is free tier eligible, right? And then the key pair. See, I think I already have a key pair, but then we'll still look at how to create a key pair. I'll just create another one so that you have an experience around how to create the key pair. So we want to select this type, this key pair type, but then let's give it a name first. So we are doing a key pair because we want to be able to be SSHing into the server. Right, so select the key pair and then the key pair name. Key pair name. I think it's almost time. It's almost time for prayer here. So I think maybe after we successfully create this backend server, we'll just take a break and then we'll come back. We'll come back later on. So I'll just select this type and then provide a. So you see, I already have a key pair with this name, so I'll just add 2 to it, and then I'm going to be using this format pen. So I'll just say create key pair. So when I say create key pair, that key pair is going to be downloaded onto my computer. So I'll just save it. Alright. So let me just finish with this specific. Or should I finish? Let me just let's finish the creation of this server first before we look at how to store that key pair. Right, so I've already downloaded that key pair, so let's just continue with click edit the network settings. So let's edit the network settings so that we can be able to provide we are going to be able to tell AWS which VPC to add this server. So I'm going to be using this VPC, right, and then the subnet. I'm going to be using this public subnet, yes, because we cannot place this server inside of the private subnet because we want it to be accessed from everywhere. Just like I told you, we don't have any load balancer yet that is going to be routing our traffic, so we have to make it public, right? So auto assign public IP address, yes, we need a public IP address so that people from everywhere can be able to log in using that IP address. So security group, we want to select existing security group because we've already created one for the backend. So we used this was the security group we created, backend security group 2. Right, next. Yes, and then we just go on to launch the instance. So these are file systems that we can attach to this what's it called? We can attach to this server. Just like your server needs to have like a kind of a storage. But for now, we don't need any storage because we are not storing anything on the server. We have our database that is going to be storing every of our changes that we make. Right, so we don't need any storage for now. So just look at it as we don't have an SSD or a hard drive connected to that server. Right, so let's just click on launch instance. So our instance is going to be created now. Right, so we can use this button to view all of these instances. So as you can see now, okay, initially I stopped one server. So this is the one that I have for my assignment, and this is the one that we just created, and it's still initializing. So we've successfully created security groups, subnet groups, our database, and then we've now created our backend server, right? And hopefully we'll not make any mistake. Okay, we need to also look at how to store that KPI, right? So, but then I think we already spent almost 2 hours. So, and I need to go for prayer actually, and then so I think maybe we have to be adjourning this class for now, right? And then maybe by tomorrow I will set another class for tomorrow so that we'll continue this assignment, because we're not going to be rushing right now. We just want to make sure that we understand, unlike previous class that we're just going to be rushing to make sure that we complete everything. But we just in this case we want to understand what is going on, right? That's what we want. So is there any questions for now? I'm going to be adjourning this class so that in next class we're just going to be continue from how we store these KPIs, right? Because we need this private KPI in order for us to SSH into that server.
Thank you very much.
Yeah, so you're welcome. I hope you guys have learned something at least today with the VPCs and all of the security groups and these are AWS resources. So is there any
yes,
other?
we have.
Yeah.
Thank you.
Okay, you're welcome. So is there any other question? Is there any other question from anyone?
Sorry, this instance you launched, are you going to be terminating it for now?
Okay, so this instance I just launched, I may terminate it. So it's not like I'm going to be terminating it. I'm just going to be stopping it. It's just going to stop running, but then all of our configurations will still remain inside. Just that our IP address is going to change. So whenever we come back, we'll not even use the IP address yet. Understand? But it's still going to be there for us to use. So even though I stop it, there's nothing going to be affecting it. You understand?
Yes.
So are there any more questions? So if there are no more questions, so I'm just going to be stopping the class here, and then I'll try my best and put another class tomorrow. Tomorrow is Monday, and then we'll try and see what we can achieve tomorrow in the evening. Right. So thank you guys for joining. And we'll meet tomorrow. So the link to the document, I'm also going to put the link to the document also in that group, and you can ask questions in the group. I'm very sure that there are a lot of people that can help you with your questions in that group. So thank you so much for joining everyone. We'll meet probably tomorrow. Bye bye.
Okay, thank you, Mohammed.
Yeah, you're welcome, John. You're welcome.
We will link.
Thank you so much.
Thank you very much.
All right. Thank you so much, everyone. Yeah, bye bye.